Hey, what's up, everybody? My name is Cameron, and we are going to build some user-facing analytics today using Kafka and Tinybird and Next.js/React. If you joined my last live coding session, we did something similar, but we kind of created some data and then we visualized it in Grafana, which is great for kind of like internal dashboarding. But today we're going to actually try to sort of build a React app and create some analytics for it. So let me jump in. I've got a lot of ground to cover today. I don't actually know if I'm going to be able to do it in 60 minutes, but I'm going to try. So before I kind of get into this, let me just lay some ground rules. First of all, if you have questions, feel free to ask them. We're streaming live on LinkedIn and YouTube and Twitter, X, whatever. You can comment on in the YouTube chat if you have a channel. Otherwise, if you have questions and you can't ask a question or your question doesn't get answered, please join our Slack community. I've provided a short link to it below. If you join that community, you can ask questions about this live stream or about Tinybird in general, and we will be happy to answer them. Last thing is that when I'm done today, after I kind of wrap things up, send an email. The email will have the recording, the GitHub repository for what I'm showing today, and then any other resources that I might mention. If I mention some blogs or docs or something like that, I'll send those as well. And if you have questions, you can reply to that email and I'll respond to it. So without further ado, let's jump in. So let's start with what we're building today. Now, hi, I'm Cameron. There's my email address if you want to email me. Here's what we're building. So user-facing analytics is something that is really in these days. It's super hot. The idea is your users are interacting with your application, your product. They're creating data as they do that. Let's create some analytics and surface those analytics back to the user. And so this is kind of what we're going to be building today. We have this user-facing application. It's going to be emitting events to a Kafka topic. And then, we'll have a Kafka consumer to consume those topics, write those to a database, and then we're going to build an analytics API on top of that. Of course, trying to do that in 60 minutes would be insane. So we're actually going to collapse this and use Redpanda and Tinybird. So Redpanda is basically a drop-in replacement for Apache Kafka, super dev friendly, super fast. So that's awesome. And then Tinybird is a real-time data platform that's going to bundle data ingestion, your real-time database. Tinybird's built over ClickHouse, and then your API layer into a single package. So it's going to make building these analytics APIs really easy. And then on the user-facing side, we're creating a Next.js app. We're going to use React components, and then we're going to use Tremor, which is this really great React charting library. We've used it in a lot of our live coding, but it's really easy to build data visualizations with. So we're going to use that. Cool. Let's jump in. Let me share my screen. Okay, so if you go to this link right here, tbrd.co/live app, it should take you to this little application that I have deployed on Vercel. And this is it's really simple. You pick a color, pick your favorite color. You enter your username. I'm going to put in Cameron. And then when you pick a color, they will change. And that's really all there is to it. It's an app, right? It's simple, but it's just the coolest thing I could think of that was also simple. But it's basically, this is a React app. And actually, if we can go look at the code, this is my app. I have this page. And basically, it's placing this component that's called color picker, which I have here. And so, what it's doing is you click on the button, generates random color. We're going to add some stuff here later, but basically it's just, updating those colors when you click, and then kind of handling that username input as well. And then it's rendering all of that. So what we want to do first is emit the events from this app to Kafka, in this case, Redpanda. So I am using Redpanda Serverless. Here's my Redpanda Serverless cluster. This is something Redpanda just recently launched. It's awesome. Basically hosted Redpanda on, cloud of your choice. And so I already have this cluster right here. It's called demo user facing analytics. And I have a topic that I was using for testing, but let's just go ahead and create a new topic just for the sake of, I'm just going to call this color picker new. And we'll just leave the defaults. And so now we have this topic. And then the only other thing I am going to do is go in and manage my access control list. So I have this user, and all I'm going to do is add a topic ACL. So color picker new, and then just allow it to do all the things on that topic. Okay, so we've got this new Redpanda topic. It has no messages on it. Let's let me hide this little banner so we have more space. Let's update our app to emit some events to this. So the first thing we're going to do is we're going to create a utility. I'm just going to call it, let's see, let me go to my React app, and I'm going to make a utilities directory, and then I'm just going to create a redpanda.js file. And what I am going to do is I'm going to use this, this Kafka JavaScript library. First, I'm going to get the use server directive because that's how this Kafka producer will work. I'm going to copy and paste some code here for the sake of time and just kind of explain it as I go. If you have questions, always feel free to ask. Here's what this is doing. So I'm importing this Kafka.js library and creating, this Kafka class called Redpanda. And then I'm just going to create a producer. Okay, and now I'm just gonna do 3 functions, and I'm just, I'm gonna copy and paste. I'm basically just going to create a connect and a disconnect function that we'll use later. These are not that important, so I'm just gonna copy and paste. You see that they're gonna connect the producer, send a message, throw an error. If not, disconnect the producer, right? And then the more fun one, which will be something like send message. And so this is actually going to allow our app to send a message to the Kafka topic. So we'll just kind of do producer.send, and then we need to find a topic. So in this case, it's color picker new. And then we need to do the messages. Actually, we need to pass a little message to this. And then what we're just going to do is we're going to stringify the JSON for that message. And then I guess just catch our error if we get an error. And we'll just log this thing. Error. Okay. Cool. Now let's save that. Okay, so we have this Kafka utility, this Redpanda utility. It's going to create the class, create a producer from that class, and then we have these 3 functions to connect, disconnect, and send a message. So let's go back to our React app here, and I'm going to just uncomment some things. So first, we're going to import that little utility. And then we're going to just add a function here to basically send that data, from the app to Redpanda. So we'll just call this function send to Redpanda, and then we're going to pass the username and the color. So that's kind of what we want to package into that message. So first, we'll construct that message. This looks like this. We're going to set a user column, call it username. We're going to set a timestamp. So we want to know when this event occurred. And I'm just going to create a new date and then do an ISO string, because always do your timestamps in UTC, in ISO, and then render it on the client, because timestamps suck. So that's like my little rule. and then I want to pass this color. So basically, here's, we're sending a message, and we're just, the topic's going to have the name of the user, the timestamp that they clicked the color, and then the color that they clicked. And then let's just do something where we log this message console, and then we're going to redpanda.send message, that function we created, and pass our message. And now we're going to use a use effect hook here in our React app. Basically, what this is doing, and actually, I want to basically just what it's going to do is it's going to connect my Redpanda, connect my producer when this component mounts, and then clean up and disconnect when it unmounts. And then I also have this little handler here, which is basically what I want to do. I'm gonna handle this in a different area, but what I want to do is pass this username to, actually, let's just leave that commented for now because we don't need it. We're going to need this later when we build in Tinybird. But then I just have this comment here to when this is a click handler on these colors. So when you go and you click these colors, we're going to call this click handler, and it's going to, one, if you haven't created a username, it will prompt you to do that. So, hey, please create a username. Cool, Cameron. And then it will create new colors for the buttons, but then it will send that color that you pick to the Kafka topic. So let's save this, and I'm just going to, for the sake of, let's just make sure this works locally, and then I can push it to main. And once I push it, then, this is where it becomes interactive, and y'all can play around here. So let's see if this worked. So put my name in here. I'm just going to open the, okay, so you can see that message, and just check my terminal. Okay, yeah, no, that's normal. Okay, so I'm just going to click a few of these, and now let's go check this Redpanda topic. And fingers, oh, look at that. We've got data. Okay, so awesome. So what we just did, as a reminder, was we built this little Redpanda utility in our app. It creates a Redpanda producer, and then it constructs a message, and it sends us to this topic that we just created. And so now, let me just close this locally, and then let me add the code I've just send to Redpanda, and then push this to main. Okay, and this should deploy our on this app. And so I'm actually curious. Let's see. I'm gonna just check my vercel deployment here. So I'll let y'all know when it's deployed, but then you can actually start sending events here if you'd like to play along. If you wouldn't like to play along, don't worry. I have a backup data generator that will support me if I need it. But I'm hoping that y'all will help me on this. So I'm just gonna open this and see. Okay, it's still building. I'm trying to think if there's anything we could do while it's building. Anyway, let's go ahead and create a Tinybird data source from this Redpanda topic. So as I mentioned at the beginning, the goal was we're going to produce these messages to a Kafka topic, and then we're going to create a Kafka consumer, write that to a database, and then publish some APIs. Tinybird's going to handle all that stuff. So the first thing is to consume these messages into Tinybird. So what I'm going to do is I'm going to create a data source, and I'm going to choose Redpanda. Let me explain myself. This is the Tinybird workspace. I'm using the Tinybird UI today. This workspace is in the AWS US East cluster region, and it's empty right now. I have 0 data sources, 0 pipes. I don't have time to explain those right now. If you're new to Tinybird, you can check out our docs and learn what those mean. They're kind of core concepts in Tinybird. Basically, data sources is like a table. Pipes are like queries, and with some nuance. But so let's create a Redpanda data source. I already have this Redpanda connection, so I'm going to not worry about creating a new one, but basically I would just put that Bootstrap server in there, give it a name, and then pass my key and secret, set the SASL mechanism, things like that. I'm going to click next, and I'm going to select this color picker new topic. So you can see these two topics showed up. And I'm going to pass this. This is the consumer group ID. I'm going to copy this and go back to Redpanda because I need to give my my user the ability to read from this new consumer group. So let's do that and then click next. And we're going to get the earliest records. And so what Tinybird is going to do is it's going to get this data. So you can see here's that data that we had on our topic. Oh, hey, look, Mary Jane. Nice. Y'all are playing along. I love it. Let's try this. Yep. Okay, cool. Yeah, keep sending me your data. That's awesome. I'm going to call this events. It's just kind of our raw events from the app. And then I'm going to set some sorting keys. So like I mentioned, Tinybird's built on ClickHouse. ClickHouse is a columnar OLAP data store. And so it stores data by column. And so what we're going to basically do is we're going to say, okay, I want you to store data based on these sorting keys. So timestamp will be our primary, and then user will be our secondary. The idea here is that if you're filtering by these sorting keys, you're going to be much more efficient in your reads because that data will be stored together on disk. So like all the same timestamps, all the same users are going to be sort of together on disk. So it's more efficient, you know, when you're constructing your data source. So let's go ahead and create our data source, and then it's going to bring in those rows. And there we go. Okay, awesome. Look at y'all. Okay, thank you, Mary Jane and Miguel, for playing along. So this will just continue to capture events that get created to this topic. So like I can create a little playground here and just select count. So you can see I have 19. I'll come in here and click a few more times and then come back here. And okay, so you can see it's kind of incrementing up as we, you know, get this data into our data source. Okay, so we have data in Tinybird. We have this app, and it's sending messages to Redpanda. Now we want to build some analytics. And so what I'm going to do, let me just see if there are any, okay, no questions, awesome. So what I'm gonna do is I'm gonna go back to my app here, and I'm gonna create a new component. Let's clear this. I'm gonna call this just analytics, analytics.js. And again, I'm gonna just copy paste some code because it's faster. Okay, so what am I importing? Actually, we don't even need these yet because we're going to build this later. I'm importing React. We're going to maintain state, and then I'm going to use these. Actually, we'll leave these off. I'll explain that later. We'll bring in Tremor later. So right now, all I'm going to do is something very simple. Just going to export this. Let's just keep it very simple. Return. I'm going to create a div here. Dive. Yes, cool. Div. Last name. I'm going to call this analytics container because I have a CSS class for that. And then we'll just create h2, call it analytics. And here you go. That's all this is going to do. Let's go to our page and let's just add this. Let's import this, import our component, and we'll just add analytics. Okay, now just look at this locally again and make sure that all worked. Of course, okay. So this is my localhost. But you can see basically I just added this little div, and it's got, this is where we're going to put our little analytics charts. So I'm going to just go ahead and push that to me so you guys can see that as well. Analytics, place. I always cannot type when I do these things. Okay, so now what we want to do, we want to build some charts, right? We want to create some charts. So the first thing that I'm going to do is just get like a live clicks tracker. So as people click, it will track those clicks and kind of just create a little tracker thing. So the first thing I'm going to do then is create a Tinybird pipe. And a pipe is essentially just a series of chained composable nodes of SQL. And then we can do some other cool things with that I'll explain in a little bit. But I'm just going to call this pipe live clicks. So the idea is that this will kind of create or get, last 5 minutes click counts, and then we'll just like group by 15 second. Let's do 15 second. So the first thing I'm going to do, so I create a node. I'm going to do something really simple here, which is just to create a time series. I'm going to copy and paste this, and I'll explain it. All this is doing is creating a time series of 5-second intervals. I guess I did do 5 second. Cool. Let's just call it 5-second intervals. So 5-second intervals for the last 15 minutes. So if I run this, you're just going to see, in UTC time, I'm getting 5-second increments. That should end up with 60 rows, right, for the last 5 minutes. And so that's just creating a time series. So I'm going to call this time series. And then what I want to do is I want to get kind of that same data from the Redpanda. So what we're going to do is kind of do this select to start interval, and then we're going to this. Let me just do this here so you can see. So we're going to select from this events. If I click this, we can see the schema here. You can see that timestamp got ingested as a string. We can obviously tweak this. We could have set this column to be a date time. String gives us a little more flexibility because we can parse it on the query side. But if you want a little better data governance, right, you might set that as a different type. But we just have it as a string. So the first thing we need to do is parse that. So I'm just going to use this ClickHouse function, parse date time best effort, which is a really nice function because it'll basically just look at that string and do its best to parse it. And then we're going to set a 5-second interval. Call this TS. Let me close this. And then we will select a count. Let's see. From events, and then we'll group 5. Okay, so there you go. So it's doing just I'm sending data. This is great. So this is for every 5-second interval, the number of clicks that we've gotten in our app. And so then all we have to do, I'm going to call this counts. And then all we have to do is just join these. So we're just going to select from time series. I'm going to give this an alias, a left join counts b on b.ts equals a.ts, and then we're just going to get a.ts, b.c. So then we're just getting order by ts. Okay. So we're just making sure that we're definitely getting the last 5 minutes of data. Looks like nobody's been sending anything for those last 5 minutes, but that will actually get us. So let me just click here some more. Let's run this again. There we go. Okay, so there are my clicks in that little interval. And now, so we have this node. I'm going to name this node endpoint. So what you can see here, this Tinybird pipe, this is a kind of a 3-node pipe. We have this first node to generate a time series. Call this node time series. And then we have the second node to get the actual counts, the aggregates from our events data source. We call this node counts. And then we have this final node that's actually querying those two nodes that we created and joining them. And the nice thing about this is it's like, this is a really great user interface to build SQL queries. We don't have to build these complex CTs or subqueries and all this, nested stuff. It's also great because if you look at each node, you can see how much data those individual nodes are processing. So like this one doesn't actually even select from a data source, so it's not processing much. Right now, this is fine because we only have 60 rows of events in our data source. As this grows, there will be some optimization things we'd want to do here. I'll show a little bit of that later. But right now, I mean, these queries are returning, in milliseconds. So now for the fun part. What Tinybird makes so easy is to turn this SQL query into an API. We just come up here, click Create API Endpoint, select that final node, and now we have this API. And what Tinybird will do is actually generate a token for that, which is a read token. So if I actually just copy this and paste this sample usage into a browser, you actually see I get this JSON response with all of this clicks data. So there's, I have this API. I have set up a read token that my app is using that I'm gonna, that's gonna be my app's token to kind of read my Tinybird APIs. So I'm just gonna add this pipe, add a read scope on that pipe to this token so that I can access it from the app. Okay, so I have my first kind of real-time data API, and actually, if y'all want to play around and do some clicks, we can go and see this, maybe see those clicks showing up. Anybody want here? I'll do it. I'll do it. Okay. I remember it's so there my clicks showed up there. So you can see how quick that is. I mean, that's being produced to the Kafka topic. It's being streamed, ingested in a Tinybird, made available for querying in a couple of seconds. Pretty awesome. So we have that API. Another awesome thing about Tinybird is you have this observability built in. So for each of my APIs, you can see the number of requests, the amount of data it's processing, the latency, errors, things like that. This is all available in the UI. It's also, we have data sources that you can query in Tinybird that give you this kind of data. Okay, so let's go back to our app, and we're going to create another component. And we're going to call, actually first, we're going to create a little utility I'm just going to call it tinybird.js to construct our URLs and return the URLs for that API. So it's basically, the idea here, I haven't shown this yet. Well, I won't spoil the surprise. Let's do this. So what I'm going to do is basically just, let me figure out where I'm just going to create, I'll call it live clicks URL. And then I'm just going to pass host in the token to, this is how that will get constructed. So like if you were building this, you have a different host, you have a different token, we've passed different things, and then we're just going to construct this endpoint. So we'll do HTTPS host, and then 0 pipes. We called that one live clicks. If you remember, we want the JSON response, and then we're going to pass that token. Now, I'm passing token as query parameter. You can obviously pass it in the request headers too. This is for the sake of simplicity. And then I'm going to create another function called fetch API. Or, well, yeah, it's called fetch API. That's fine. So just a little async function. We pass the URL, and we're going to do some state stuff in our little components that we build later. So it's going to get the data from this URL, and then it's going to format that as JSON. JSON, and then it will set the data. So it will handle state in our component. And then what did I do? So, yeah, okay, this is fine. Making sure I got all this right. Yeah, that should be good. Okay, and then we're just going to export our functions here. Fetch our function there, fetch API, and live-clicks URL. Okay, now let's go back to. Well, now we're going to do something fun here, which is we're going to create a component. So let's go back to components, and I'm going to create a liveclicks.js. And so what this will do, this is going to kind of be our visualization component in the app. And this is where we get to use Tremor, which is kind of these really cool visualization components for React apps. They're just basically drop in, and they're beautiful. So I'm going to go ahead and get a title, and we're going to use the tracker Tremor component here. I've already installed Tremor, so I don't have to worry about this. And then I'm just going to do some copy and paste here. Okay, so we're importing a React, use state, use effect hooks, and then the stuff we just added to this tinybird.js file. And then we're going to kind of create this component. So just looking at time, yeah, I think I've got time. So start with, I'm going to pass these host and token props to this component. And first thing we're going to do is set the state for the data. So I'm going to use the useState hook. And if you remember, that API returned a timestamp TS. So we're just going to set that to empty string, and then a C count, set that to 0. Okay, so now we have this little, where do I need to? Okay, so we're setting that state with that use state hook. So the next thing we're going to do is we're going to define the URL. So we're going to basically pass the host token to that liveclicks URL that we defined, and then we're going to basically use a use effect hook so that we fetch the API anytime we're going to add the URL to our dependency array, such that we fetch the API anytime that URL changes. So this actually isn't really that important for this one because we're not passing any parameters. But I'll show one in a second where we're doing that. We actually probably don't even need this right now. But if for some reason the API changed, the URL changed, or something like that, this would just would call that. And then the other thing we're going to do is I'm going to use the same use effect hook, and I'm just going to copy and paste this for time. So people talk about real-time dashboards. One of the things that we are doing here is we're using APIs. We're actually going and fetching the data. We're not caching anything. And the reason we're not caching anything is because we're assuming that data is being created constantly, and we constantly want to refresh these analytics. So we're going directly to the database every time. And so I am basically creating this use effect hook in my React app that's going to fetch the API every 5 seconds. Is this best practice? Auto refreshing dashboards, you're obviously making an API call every time. So that could get expensive if you don't meter that in some ways. For the sake of this demo, it's fine. I just kind of want to show how this data gets updated without having to click any buttons. There's some other React hooks that you can use to kind of manage this. There's a lot of ways you can do this, but for now, I'm just creating this use effect hook that's going to refresh my app or refresh this component every 5 seconds. And then it will kind of just do that based on this data. Yeah, okay. And then the last thing I'm going to do is I'm just going to kind of do some formatting on my tracker. So I'm just taking the data that I get, and I'm creating a color and a tooltip for my Tremor component. So let's return this component. So I'm going to create a card. And then we're going to use these Tailwind classes that I've already just kind of figured out for this app. We're going to create a title. We'll call it Live Clicks. And then we're going to pop in this tracker. And we're going to do data equals, and you can see we mapped this constant as rows. We'll call that rows. And that should be all there is to it. We're going to export that component. Okay. I'm trying to figure out why this is problematic. Why this Tinybird, why it's complaining about this. I don't think it should be. What did I do something wrong here? Okay, I guess we'll find out. If somebody can, ping me in the comments. There's a typo in line 7. Somebody helped me out. Thank you. Thank you, Isidro. Much appreciated. 7 minutes ago, you shared that with me. Okay, awesome. Okay, now so we have this component, and we're going to add it to our analytics. And so we're going to, let's see. Well, first of all, I'm going to define the host and the token to read these. Now, don't get mad at me. I'm doing this directly in the app for the sake of time. We're just going to have this, constant Tinybird host, Tinybird token. Obviously wouldn't do it this way, but I'm doing it this way for the sake of time. And then let's just kind of let host equal Tinybird host and let token. Okay. Now let's create some analytics here. So we're going to do, actually, shoot, I've already done this. This needs to go up here. Okay. And now what we're going to do is we're going to, first, I'm going to import these components. I'm going to get a grid in here. I think that's all I need. Yeah, that should be it. Yeah, cool. Okay. And then we're just going to add this grid, and we're going to, and I guess we want to import that live component, don't we? Cool. And then we're just going to drop live clicks in here. And we're going to pass the host and the token. Okay. Boom. All right. Now, let's see if this worked. So let's run the app here locally. I'm going to click on this. I'll just pull it up here. Okay. Hey, sweet. All right. So basically what you can see is we now have this little Tremor component. It's this nice tracker. It's got colors. It's got tooltips. And every time y'all click things, it's showing up. And again, it's refreshing every 5 seconds, and that data is streaming in. So now I have this view of just like the number of live clicks that are happening. One of y'all has probably already written a script to like click these, click these without having to do anything. Okay, so this is cool, but now let's do something a little more fun, which is let's create an API that will like tell us what the top colors are. So you'll notice like we're generating these very random colors, like so if you look at, it's kind of just these random hex codes. It's totally all over the place. So what I want to do is basically, I want to create this API. Actually, let me push this to main so that y'all can see. No, not Siri. I'm not talking to you. Siri thinks I'm talking to you. Hit push.
Okay.
Okay. All right. Now that'll build, and y'all can play with that on the app. You should hopefully see those as well on your end in the Vercel app. Now let me go back. That's full build. You can get rid of the local. Yeah. Okay. We're gonna wait for that to push. We'll see that. Al is definitely clicking like this is you. You're gonna we're gonna build a leaderboard. That'll be the fun thing. Assuming we have time, we're gonna go fast so that we can do this. We're gonna build a leaderboard. Okay, so let's create a new Tinybird API. And what I'm gonna do is we're gonna create a pipe to give us the top colors. So we're just gonna kind of rank the number of colors that people click, and so we can kind of see, you know, the top colors that everybody is. See what people's favorite colors are. What we're going to do is we're basically going to try to match these hex codes with the closest color. So I actually have, I'm going to pull in this colors.csv. This is just a little, I'll show this in a second. You can just drag and drop a CSV into Tinybird, super cool. But basically what it has, I'm going to call this name of the color, and kind of what I figured was its nearest RGB representation, so like red, orange, yellow, green, blue. And then I'm just going to kind of like calculate a distance from this. So I have this colors data source in here now. So let's go back to our top colors. So the first thing I need to do is kind of do a hex to RGB. And actually, I'm going to select from dense. So we're going to select the color itself just so we can see. And then this is a lot. So let me just copy and paste this. But there's some cool ClickHouse functions happening in here. Basically, what I'm doing is I'm getting, the characters from that substring. So the R character, the first two would be the R, the second two would be the G, the third two will be the B. And then I'm unhexing them and sort of reinterpreting them as a uint8, which will give us the RGB values for these colors. So let's see what that looks like. Okay, cool. So these are every color that has been clicked, and I'm getting the RGB values for that. So let's call this XRGB. So now let's create another node to basically calculate the distance from each of these colors to our actual colors. So to do this, we're going to use a cross join. So basically what that's going to do is for every color event that gets sent, it's going to generate a row calculating the distance from each of our representative colors. So we're going to select I want to create some aliases here in a second so you'll understand what I'm doing. That's just here. Let's just do this from hex RGB. RGBH. Okay, so there you go. And then we're going to cross join colors C. And then so we'll do like a C.name. Its name. Let's get our commas in here. And then we're going to use another cool ClickHouse function, which is it's basically the squared distance between two arrays. So we're going to pass, h.r, h.g, h.b as an array, and then we're going to pass c.r, c.g, c.b as an array, and it's going to calculate sort of the distance. So it's, if you think of the color on a 3-axis area, it's going to calculate that distance. We're doing this cross join. We're going to order by color descending, distance descending, and then we're going to limit 1 by color. So basically what this is going to do is it's going to calculate actually that should be ascending. It's going to calculate the distance. It's going to spit them all out for every color, and then it's going to sort them by the distance from smallest to largest, and then only take the top one. So if you do that, you can see, for each of these colors, this makes sense. FFE, FFA, that's pretty close to white. And so it's matching. So it's actually matching these colors, these sort of categorical colors. By the way, I'm not sure how perfect this is at actually matching. I did a lot of research on this. Apparently, Wayfair has done some really cool work on this. They have like image analyzers that will look at the image of the product, and then they'll like do this on machine learning models, and it's insane. It's really cool. This is very simple, but we could do some really cool stuff here. So you might click a color and be like, "That's not orange." Don't worry about it. It's fine. That's not the important thing here. So then the last thing let's do is just on this endpoint, we're going to select name, select count. So we're going to get the number of colors that have been clicked from. We're going to group name order by C. All right. Holy moly, y'all really have been clicking. Green and purple tied for the lead in terms of whose favorite color. So let's create this API endpoint. And I'm aware that we're running out of time. I might go over, y'all can stick around if you want. Okay, so we have this API endpoint now. Awesome. It's called top colors. It's the same host, same tokens, stuff like that. Actually, we are going to add that pipe to that token, add that read scope. Okay, now back to our app. Let's create a new component. We'll call this top colors. But first, let's add a top colors URL here. So we called this top colors, passing that host and token, and then just export it as well. And then I'm going to copy and paste this live clicks component because it's almost all the same stuff. And we're going to put it in this top colors component, and we're just going to change some things here. I'm going to use a dreaded donut chart. Don't at me. It's fine. And then everything else pretty much stays the same. The only actually thing here is we're going to do some different mapping. Let me look at what I did. Pull up that component. So we have instead of a TS, we have a name for the color. Top colors URL. Fetching that again, same refresh interval, and then we're going to just do some different kind of mapping here. I'm going to paste in what I already have. Basically, we're going to pass a name, we're going to get a value, and then I'm actually going to change the color of the donut chart kind of component here. The only one that doesn't have an existing name is black. So I'm using zinc, which is this tailwind color. And then we're going to create some labels here for a legend. So we're creating our colors, our labels, and then I'm going to, let me just copy and paste this, and I'll explain it. So we're going to create kind of another class. This will be a flex class that has a title. It's going to have a donut chart. We're going to hide the label. We're going to show the data. We're going to have the colors, and then we'll have this this legend as well, which we imported donut chart. And then export top clicks. And export this component. All right, back to our analytics, and we're just going to copy, paste, top clicks, and import top clicks. Okay, let's run local again. I don't know why I keep closing it, and whatever, it's fine. What did I do? Let's go back. Top clicks. Top colors. Top colors. Right? Did I change the name? Nope. There's my mistake. Okay. What have I done? Top colors. Top colors. Right? That's what I called it. Top colors. Yeah. Okay. Wonderful. Okay. Boom. Check it out. Okay, so we have this little pie chart, and it actually has kind of the top. Look, this isn't the best way to do it. We might actually do like a leaderboard style, but since I'm going to create a leaderboard, I wanted to do a little pie chart. Let's do something fun here. What I'm going to do is, right now, this is showing us the top colors that every user has clicked. Let's show the top colors for just you if you want. So let's we're going to go back to our Tinybird API, and so let me just get rid of this, and we're going to go to this top colors API, and what we're going to do is pass if defined. So I'm doing this where one because we're going to use some Tinybird templating, and we're basically going to say if defined user, and we're going to pass a filter here, and username user equals, and we're passing, this is where some fun stuff with Tinybird. So we're creating a query parameter that's called, I'm just going to call it username. I don't know if this will get confused between the column that we have. So now basically if I pass a username, it will filter. And actually we just released this cool new UI feature where you can actually test these dynamic parameters. So let's just test some values here, and I'll pass Cameron because that was mine. Test our pipe, and we should get, yeah, see, look, different results. So this is my leaderboard. So I love purple and black. And if we reset that, it goes back. So now we have this kind of personalized API. So let's go back to our code here. Going to pass another prop to this username. And actually what we're going to do is, because we want to, we're going to do, what do we want to do? Pass username equals, basically if username is not defined, we'll just pass, well, how do I want to do this? I've already done this, so let me just make sure I don't flub it here live, because it's not worth wasting our time. Utilities, Tinybird, constant pass username. Yeah, pass username. Do a username. Okay, yeah. If username exists, we'll do an and username equals, and then we'll pass that. Use my backticks. Otherwise, pass something in the username. Okay, and then we're going to just do this pass username here. So basically that will add a query parameter to that. And then the last thing we need to do is back in our color picker. Remember this, right? We have this handler here. So what we are going to do is you go back to the app. If you enter, let me refresh you. Vercel not built this? What did I do wrong? What'd you do? Surprised. Okay. I don't know why that's not updating on y'all's end. It should be. Well, let me fix it. So passing username. So basically what we're going to do is we're going to take that, we're going to add, so this is the input component. When you go out of that, on blur is the handler here. We're going to pass the username, and it's going to basically just have this unusername change, and we're going to pass a username prop to that. I guess what did we do to? I don't even remember how I did this. It's probably not that important. Tell you what, I'm not going to worry about this for right now. Let's move on, because I want to show one more thing, which is I want to show how to. I'm just wondering, why did stuff did push? I want Vercel to build that. Anyways, we can continue to show the local one if Vercel doesn't want to do that. That's fine. Let's create a leaderboard. I've got 5 minutes. We can do this. Okay, so we're going to show, I'm going to show just kind of some optimization here. So one of the things you may have noticed if you are a data person is I'm just calling this events data source. Well, right now it has 2,000 rows. That's nothing. We're not worried about that. Even if it were 200,000, I wouldn't be particularly worried. But if my amazing color picker app goes gangbusters, this could be 2 billion, and then querying this data source would be really inefficient. So in Tinybird, we use Materialized Views as a really powerful optimization lever. So we're going to create a leaderboard of people who are clicking, and then I really want this to deploy so that y'all can play. I'm not sure why it's not, but anyways, I'll show it locally. Y'all can still play along as you click the colors. Let's create a new one. We're going to create this pipe. So in Tinybird, Materialized Views start with pipes. We define SQL, and then we use that to build our Materialized View. So all we're going to do here is we're going to select, and we're going to do a user, pass that user, get a count as clicks from events, group by user. Right. Okay. So you can see we've got all these users and all their counts. Not Al. Al and not Al are crushing. Way to go, guys. Or guy. I think it's just one of you. Okay, so what I'm going to do is instead of doing this query and publishing it as an API, I'm going to actually create a materialized view. Actually, this is a there we go. Okay, I had to run it. So we create a materialized view. What this is going to do is it's going to take the results of this pipe, and it's going to create a table in our database. You'll also notice it's going to use some modifiers here. I'll explain that when I query it. But it's going to, and then I'm going to set my sorting key is user, perfect. Click next, all the rows. Okay, so this has now created this leaderboard MV data source. You see this and you go, what the heck are all these? What Tinybird is doing is it is storing for each of these rows an aggregate state. And so if you go back to our pipe, you can actually see that Tinybird added this state modifier. So it's creating this aggregate state, and when we query it, we're going to merge the results. So now we can create another pipe. We'll call this get leaderboard type, and then we're just going to select. It's kind of that same thing, except here we're going to do a count merge as clicks from leaderboard MV, and then let's by user and clicks. What did I, clicks. Okay. And so there you go. So basically what I'm doing is what is happening with the materialized view is as you're ingesting data, so as Tinybird is getting data from this Redpanda topic, it's constructing these aggregate states, and it's continually calculating those aggregates in the background. It calculates them every few minutes or so, and then we can just do this final merge at the end. So what you'll see here is that this query, instead of, if I just did events here, like if we had this, you can see, well, hold on. If I just had, let's just, here, what if I just do from events, right? If I just count from events, get rid of this count merge, and I just do a count, right? I'm processing 2,000 rows. But if I do my leaderboard MV and I merge, now I'm only processing 14 because that's how many users I have. So very, very efficient. And now I can, let's call this endpoint. This is not necessary, by the way, it's just for hygiene. And I'm going to create my API. Now I'm going to do this really fast because I'm almost out of time. Let's go and just do some copy paste stuff. So we're going to first go to our Tinybird. We're going to do constant leaderboard. Actually, you know what? We're copying and pasting, y'all. Time is of the essence. I always can't find this file. Okay, so we're going to define this API. We are going to turn it from our Tinybird thing, we're going to create a leaderboard component. I am going to copy and paste. Let me explain it. I am going to, what did I have? Oh, I'm not using this anymore. Here's what this is going to do. And oh, actually, let me do something. One of the things I didn't do on this Tinybird API is add pagination. So I'm actually going to create some pagination here using query parameters. So what we can do is limit, and I'm going to call this page. Let me make sure that I'm doing this right. I don't want to. Yeah, so we're going to limit. We're going to create a uint 16, call it page size. And we'll just say our default leaderboard page is 10. And then we will offset. So this is going to allow us to do this pagination page. Default will be the first page. And then we're going to offset it by the page size. Okay, get that right. Okay, cool. So now you can see we have this, this page size. Make sure I got that all right. Yeah, it should be working. Oh, I think this one. Yeah, 0. Okay, cool. So let's then go back to our Tinybird. If you look at this, you can actually see that I passed this page size in this page. And then let's go to our leaderboard. Just make sure y'all know what I'm doing there. So again, it's going to use that same refresh effect. It's going to create this URL. And I guess I didn't add this to the component, did I? Or maybe I did it in. Yeah, okay, here's what it's going to. So then I'm going to go. So I have this component. I'm going to go back to analytics here. And I'm going to call, let me import it. Bear with me, y'all. We're almost done. Leaderboard. Not oh, I need to. That's working. Okay. Export, import, leaderboard. Okay. We'll add this leaderboard. And we're going to do post. How do I want to do this? All right, you know what? We're going to paste this in again because time. Okay, so we're at leaderboard. We have this host, this token, this page size, and then this page. And then I've got these little nav buttons that I'm adding. And one is to go left, one is to go right. And I've just created these little click handlers. Let me paste those in. So we're going to use date in React to set the page. We're going to start at 0. And then basically just, if somebody clicks the left nav button, it'll go back a page, assuming the page isn't already 0, and it'll go forward a page if we click the right button. So now let's see if this works. Nope, something broke. Let's go fix it. What did I break? I hate it when this happens. Where you let's see. What did I did something wrong. Failed to load reset. Okay, I didn't get a something was wrong with my URL. Get leaderboard.json. Oh, I know what it was. I didn't give my pipe permission to read it. Let me add, nope, not that one. Add the get leaderboard to my token. That ought to fix it. There we go. And now we have this nice little paginated leaderboard. So when I click these little nav buttons, it's actually calling that API and it's kind of getting the offset. And so you can see if, like, here, I'm going to try to spam and climb up the leaderboard here. There I go. I'm climbing. So there we go. That's it. I'm 5 minutes late, but we did this, and yeah. So I hope this was helpful. Maybe I'll just kind of see like this end to end. Like we created a React app, we sent that data to Redpanda, to Kafka, used Tinybird to consume that data, write our SQL queries, construct our analytics, and then publish these APIs that we could then integrate back into our app. Let me go see if anybody had any questions. Nope, it's just people telling me all the typos that I had. Al, don't make fun of my commit messages, man. Time, baby. It's all about time. Yeah, that's it. Like I said, I will make this repo public, the final version that actually works, and then send it in an email along with this recording. Again, if you have questions, please join our Slack community. It's a great place to ask questions about Tinybird. Of course, you can always reply to the email that I will send as a follow-up and ask your questions there as well. I'm going to send that email from my email address. So if you reply, it will come to me. If I don't know how to answer your question, I will ask the many, many, many people at Tinybird who are smarter than me for help. But yeah, if you want to sign up for Tinybird, tinybird.co/sign up, free to start, no credit card, no time limit. Everything that I built today was free. I don't know if it would be free. I don't know if the Redpanda side would be free for you, but it was free for me just because we work with Redpanda a lot. But the Tinybird side was free. No, free, real free. Everything that I did was free. You get 10 gigabytes of storage and 1,000 API requests a day on that free plan. So, yeah, appreciate everybody joining. This was fun. I did it in 65 minutes. That's pretty good. I'm pretty proud of myself. If you have more questions, again, just feel free to ask. And otherwise, stay tuned. See y'all later.